So here we go. A good morning from my side, ladies and gentlemen. I have the pleasure to kick off the technical part of JPoint. And well, in the spirit of this conference, this is actually a quite technical topic that I have with me today for you this morning. It is a story about Spring Framework 5's development effort, how we upgraded our baseline to JDK 8 and made the best possible use of the facilities in JDK 8 from a framework perspective, and how we started to embrace and adopt to JDK 9 conventions, more like JDK 9 plus conventions, really. As you will see in this talk, every time I'm saying JDK 9, I really mean JDK 9 and higher, since JDK 9 is just the beginning of this new sequence of releases that we get every half year now, JDK 10, JDK 11. If you're saying 9, at this point you already mean 10. In half a year, you will mean 11, right? So this is also something we're going to talk about towards the end of the talk, how, from a Spring Framework perspective, we deal with this new world that we're in terms of JDK releases. A few words about myself. I have been leading the Spring Framework project since its inception, so I've been doing this job for about 15 years now. It's a kind of 15-year anniversary also of the framework itself. The first release was in, the first official Spring Framework named release was in June 2003. So literally almost 15 years ago. And I got involved in December 2002, January 2003, so also more than 15 years ago already. Spring Framework in this context means everything you can find on GitHub, like github.com/spring-projects/spring-framework. This is basically my responsibility, and this is also what I am going to talk about today. A fact sheet, right? This is not too relevant for what we actually will focus on, but this is sort of the executive summary. Everything Spring Framework 5.0 is doing, it's actually already out for half a year. We released it just a week after JDK 9's GA last September, and it does many things. It is probably best known for the introduction of Spring Webflux, our parallel reactive web stack. I will be talking about Webflux and the reactive design story behind it in my talk tomorrow. This is not a particular topic today. It will sneak in a little, since it connects really nicely with the use of Java 8 language features. A very important effort is always the baseline upgrade that we do for major releases. Literally, the framework is now JDK 8 plus based throughout the entire code base. We really mean this. It's not just compiling it on JDK 8, it's making the best possible use of JDK 8 library and language facilities. And last but not least, there was the Java EE 8 release around the same time, Servlet 4.0, JPA 2.2, bin validation 2.0, which we also dealt with in the context of this release. But let's move on to a particularly important factor in running an open source project. Spring Framework lives and breathes through the community. Everything we do only matters because it is being used out there, right? Because you guys are using it. It also lives and breathes because there's a lot of feedback coming back to us. Ever since we moved to GitHub a few years ago, we get strong contributions as direct pull requests. Not just the Jira issues, catching a little snippet of what could be done, what could be improved, but an actual pull request addressing an issue, refactoring something, polishing a bit of code, ready to be merged into the code base right away. And there are many contributions out there, in particular also from the Russian community, and I'd like to highlight a particular one. Dear Igor, I suppose you're actually with us today, as far as I heard up front. You really beat it here. I looked it up last weekend. You had a grand total of 50 pull requests. As far as I'm aware, all in the past quarter, so just within a pretty short time frame. And we closed 50 pull requests in a very short time. my immediate peer, Rosen Stoyanchev, on the Spring Framework project, actually called it a denial of service attack towards me, because I dealt with almost all of those pull requests myself. I'm very much of the actual maintainer of the core of the framework myself here. So I reviewed and merged most of those pull requests. Actually, they triggered follow-up polishing. Many of the pull requests point out a specific issue, and we realize, oh, yeah, good point. But there are actually other points in the framework along the same lines that are also worth refactoring, that are also worth addressing. So this created a really huge maintenance upgrade of the code base in very specific corners, not least of it all towards the proper and consistent use of Java 8 language features. So thumbs up for all those pull requests. They came at a perfect time. And all of them, as far as we merged them, are actually to be found in the Spring Framework 5.0.5 release that just went out a few days ago. All right. So, towards the main topic of the talk, one of the two. JDK 8 is probably the most important Java release of the past decades. In the meantime, I would argue it is more important than JDK 5 was back at the time, but it certainly is at least at that level. The influence that it brings, the inspiration that it brings towards the ecosystem, towards the frameworks, the libraries, and of course all the applications out there is enormous. I couldn't foresee how strong it would be even for us. So we actually dealt with it in two phases, as you might realize, and as you might actually wonder. Because didn't Spring Framework 4.3, or the 4.x line, 4.0 to 4.3, didn't it have strong Java 8 support already? I mean, if you were using Spring Framework 4 or 4.3 on Java 8, in many ways it actually feels like a Java 8-based framework to you. It naturally, reflectively mostly, adapts to your code. If you choose to use Java 8 language features, even in your method signatures, even at your injection points, if you choose to use Java util optional, for example, the framework naturally understands it. This was a compromise we made. Spring Framework 4 can still run on Java 6 and 7, but if it runs on 8, it enables many extra features automatically, just by the very presence of Java 8 underneath, for you. So from an application development perspective, there was actually a lot of Java 8 stuff already available. And this is purely a timing issue. We wanted to have a full, complete Java 8 development story, development experience against Spring, when Java 8 was released in early 2014. This is why we rolled it into Spring Framework 4.3. And in many ways, it was already anticipating further steps to come in 5.0. So 4.3 and 5.0 really were kind of two sides of the same coin for us, our mission to deal with Java 8. So there's a lot of alignment, but also there's a lot of stuff that we could technically simply do. Really kudos to the JDK team. The way that they implemented many facilities in Java 8 was designed very wisely. Functional interfaces, being a convention that you can also adhere to in a framework that is still Java 6 based. You don't have to annotate a functional interface with add functional interface. You can, but you don't have to. They implemented it as a compiler convention, which really allowed us to do what we did here in Spring Framework 4.3. By late last year, this is a survey from October last year, we found what we expected, a strong dominance of Java 8 in at least a certain part of the market out there. I mean, we always need to take surveys with a big grain of salt, but it is quite representative. In this particular survey, which was among a certain ambitious Spring-minded audience, I suppose, we had almost straight 75% use of Java 8, very little use of Java 6 left, almost negligible use of Java 9 yet. I mean, it was just a month after its release. This is exactly what we are waiting for. This point of time is what we need. This dominance of a particular generation of Java is what we need in order to require that Java level in a new Spring Framework generation. And Spring Framework 5.0 went out about 2 weeks before that survey. So as a Java 8 requiring based framework. The baseline in Java 8, the Java 8 baseline in Spring Framework 5 brings many, many benefits. And I'd like to highlight a few of them in this section of the talk, because even if most of those things really matter most to us as the framework maintainers, as the framework developers, as the ones evolving the code base, they also shine through to you in many ways. In particular, if you'd like to contribute to the framework, then you can immediately benefit from its Java 8 nature internally, but also as API consumers, as applications that interact with the framework. So there's a few very obvious things we can do. In the meantime, we internally use Lambda expressions, method references, but in particular features like the collection stream API in Java 8 quite heavily across the code base. Imagine that that a code base that really grew from JDK 1.3 compatibility to JDK 5, then to kind of a JDK 6 baseline, and now to a JDK 8 baseline. There's a lot of history in that code base, right? A lot of legacy. The only way we can deal with this is by not really letting it become legacy, refactoring it, updating it every couple of years, every time we do a major release. So we went through literally the entire code base. I'm not entirely sure we touched every single source file. I'm pretty sure we didn't. But we touched most of it. We touched a high percentage of the Spring Framework source files, updating everything we can to Java 8. Everything that also improves readability or even improves the runtime behavior. Some of those features in Java 8 are not purely aesthetic, not pure syntactic sugar, right? They actually enable more efficient locking behavior. Takes, for example, the concurrent map improvements, concurrent hash map, compute if absent. There is a certain balance between aggressive locking and lenient concurrent interaction that we can only do now that we're Java 8 based. So we made very selective use of those, but also very strong use of the syntactic sugar to improve the readability and maintainability of the code base all across. And this is also where all the pull requests really helped, because it is a huge code base, right? We can't find all those spots ourselves. It's really particularly helpful if external fingers come along and put at the right spots in the source code that would benefit from a little bit of improvement towards Java 8 features. A very important enabler, being based on Java 8 now, requiring Java 8 now, is being able to expose Java 8 API types in our signatures. In Spring Framework 4.3, we could do things like reflectively detect your use of Java util optional, of java.time duration, anytime you were declaring this and we reflectively found those, we knew what to do. But we couldn't have those types as imports, as arguments, as return values in our own signatures, in the Bean Factory API, in JDBC templates, in menu-related interfaces and classes that we have in the public surface of the framework. As of Spring Framework 5, we can do exactly that. And there's important stuff. There's completable future, there's the java.time types, there's improvements in the reflection APIs in Java 8, actually. Quite a bit of it. There's executable as a base type of constructor and method, more efficient ways of finding out about parameter declarations or about declared annotations. Again, improving runtime performance, but also improving interaction with other reflective libraries and frameworks in quite a few places. Most importantly, there is, of course, the Stream API and the Java util function, the collection improvements related to the Stream API, and the Java util function types. The Java util function package in Java 8, providing common callback interfaces, pretty simple, straightforward interfaces like a supplier, a consumer, a predicate, that Java 8-based frameworks and libraries can agree on, and that are perfect candidates for being used with Lambda expressions, and method references, of course. I'll show you an example in just a moment. Last but not least, default methods. Default methods in Java 8 have been introduced mostly as a feature to address the evolvability of interfaces, right? Being able to declare new methods in existing interfaces to provide a default implementation so that existing implementers of this interface are not broken right away. This is great in its own right. Basically, being able to evolve an interface in a backwards compatible fashion is great for us, and we're making heavy use of this in Spring Framework 5.0. But we found that even more importantly, we started using default methods for convenience, for the convenience of you implementing callback interfaces in Spring or implementing SPIs in Spring. So many of the interfaces in Spring have been refactored towards stronger use of default methods. Even existing methods have a default implementation now if they easily can. Think about, for example, the bean post-processor interface, those kinds of handler interceptor in Spring MVC, those kinds of callback interfaces with several methods, where oftentimes you're only going to implement one or two and ignore the rest. Stubbing out the rest through default implementations in the interface was really beneficial. Previously, we had adapter classes that you had to derive from as a base class that had those stub methods. It's much nicer if the interfaces themselves provide those stubs. So we really started to embrace Java 8 default methods more than we thought we would. All right, a few examples of what this really means. Just a particular favorite of mine, you might not actually know it quite yet because it's reasonably new, the object provider interface for injection points, where you're just saying, auto-wired, not my bean itself, I want an object provider of my bean, which is kind of a flexible retrieval API for my bean instances that you use on demand rather than insisting on getting the instance right away. The original version in Spring Framework 4.3 had methods like, for example, getIfAvailable, getIfUnique. Kind of, you're basically expressing when and under which conditions you would accept a particular instance. The 5.0 revision of it has a few new methods now. For example, it has a getIfAvailable variant, an overloaded variant, with a default supplier. So give it to me if it's there, otherwise create a default instance here. Supplier is Java util function supplier and is usually being used with a method reference or a Java 8 Lambda expression that just says like, here I'm creating the default instance, but only if it's actually being used, if there is no corresponding instance available. We have that for getIfAvailable and getIfUnique, but there's even an almost nicer variant, like I'd like to do something with an existing instance if it's there, otherwise I have nothing to do. Well, there's an ifAvailable consumer method, where you're saying ifAvailable, Java util function consumer, with a Lambda expression usually. So you can have a one-line expression that says, if that object is there, I'm doing this with it, otherwise I'm done. Really nice convenience methods, providing tight integration with Java 8isms, with Java 8 language and API design in a backwards compatible way, because they have been introduced onto an interface that we had in 4.3 already. So this is essentially, in many places in the framework code base, what we have been doing for you in 5.0, taking the framework and kind of moving it, extending it, refining it towards a Java 8 plus world, with close integration with Java 8 language facilities. The higher level features, and I'm going to elaborate a bit more on this tomorrow in my talk, even allow for some pretty unusual style in terms of, for example, bean registration. So in Spring Framework 5, if you wanted to set up an application context with just a few beans, and you wanted to do this in a different way, right? Not annotation-based detection of annotated components, no class path scanning maybe, then there are new facilities for you, actually very straightforward ones. Instantiate an application context, register a bean by class, and typically by what we call an instance supplier. So the register bean bar.class here basically is the component type. And what follows is an inline Lambda expression that says, if the framework decides that it needs a new instance of the bar component type, then it will dispatch to this provided instance supplier in order to create that new class, that new instance. That new instance of course, can accept references to other instances by programmatically calling back to the container. So we have the new bar, context is the reference that we originally had. We're just calling the retrieval methods if we need, for example, an instance of food to be passed into the bar constructor. This is actually pretty sweet, in particular for a smaller, well-controlled application context with just maybe 5, 10, 20 types to register. This may still fit on a single screen, depending on how you design those components. And there's many twists. The second example below, has another inline lambda expression, fine-tuning the resulting bin definition. So it's basically equivalent to the above, but it adds a bin definition customizer. We call this a bin definition customizer. It's a var arg, so any number thereof. You may set lazy init flags, add qualifiers, add bin definition attributes, whatever you like in one-line lambda expressions, any number thereof when you register a bin. This is what we aimed for when we said we wanted a more functional style. We mean functional as in Java 8's functional style, like in Java 8 functional interfaces, like in Java util function, like in Java 8 collection streams. That sort of experience can also be provided here. We're taking this to several levels, not least of it all within our new reactive web framework, Spring Web Flux, into the registration of web endpoints. So a simple example, I'm also going to elaborate a little bit more tomorrow on the context of this, just taking the source language perspective for today's purposes. This is a little snippet that basically says, let's create what we call a router function, where we're saying for an incoming request predicate, a request matching this predicate, like a get users request, we assign a handle function, and we use Java 8 method references in order to do this. Handler function is an interface that accepts a server request coming in and essentially has a server response going out. So all of the referenced methods, according to Java 8 conventions, have to be compatible with that interface callback signature in that handler function interface. So this is exactly what you get here. Let's not be concerned too much about what Mono and Flux do here. Those are essentially the reactor types modeling a reactive stream that is capable of producing a sequence of objects or a single object or none at the time when those elements can actually be produced and consumed. So this is part of a reactive processing chain. But aside from all the reactive nature, there's also quite a bit of language design shining through here. Maybe this looks a little more on the unusual end to you, although it's actually somewhat close to what annotated request mapping methods look like in the end. Different compromises, right? No flexible signatures, no annotations, fixed signature as a target for a method reference here. And not just as a method reference, the exact same API can also be used with lambda expressions, because according to Java 8 conventions, this all ends up with the same compiler convention, right? So if we wanted to refactor this example into inline lambda expressions, it would look like this. The router function is basically now a single statement. We're saying here's the route, and for the user's ID part, here's the inline lambda expression that implements the handler function, and there's another route for get users, again an inline lambda expression, knowing what to do when a request of that kind actually comes in, so that the runtime infrastructure can dispatch to these methods, getting the processing chains for each of those requests, and then calling them back as data comes in, as back pressure allows for it. So they said there's a close interaction with the runtime processing stack, but there's also very close alignment with the Java 8 language conventions here. All right. So of course, we are not the only ones having gone through a Java 8 baseline upgrade in 2017. There's many others, and I'd particularly like to highlight JUnit 5. We have actually been sponsoring JUnit 5. One of the committers on my core Spring Framework team is also a strong JUnit Jupyter committer. So we kind of co-evolved to some degree. And in Spring Framework 5.1, we also follow the JUnit 5.1 upgrade, and it's close to Gradle integration and many other things. There's close collaboration here. But JUnit 5 also went through the same kind of JDK 8+ upgrade. They kind of reinvented JUnit from its quite old JUnit 4 heritage to a modern Java 8-based framework with modern Java 8-based SPIs in particular. And there are many others that are also Java 8-based in the meantime. Not all of them have gone through the same full code base upgrade, but they are at least all formally requiring Java 8 as a minimum now. So let's move on to the second part of kind of the story, right? JDK 9 and higher. While we happily use Java 8, right? And apparently, this really is the industry norm in the meantime. And I'm personally very grateful that Java 8 managed to establish itself quite quickly as a sort of reference out there in the industry. Maybe at this opportunity, a quick check: who's using Java 8 in production code? Or maybe let's invert the question. Who is using JDK 7? Few hands. 6, anyone? OK, now let's move it to right here. Anyone having production development or code that is to be put in production this year on JDK 9 or 10? Cool. This is exactly where we find ourselves, right? Personally, I find it most important that we have JDK 8 as a common baseline now. In many ways, JDK 8 is the new JDK 6. It is what we can all agree on. It is what almost everybody, is using, right? Or can look forward to using very soon in any case, right? But there's already a future emerging, and that is JDK 9 and higher. Let's start with the very JDK 9 release itself. A little bit of a personal summary, because personally, I find a lot of goodness in JDK 9, in particular in the general JVM improvements. The complex strings features is a great idea. We have G1 as a default garbage collector now, and it's actually an upgraded version of it. We have the ability to customize JVM distributions. I mean, JDK 9 is a heavy refactoring of the JDK itself. The JDK doesn't look anything like what it looked like before for so many years. It actually is a really quite aggressive refactoring, but also coming with many benefits, like being able to create customized JVM distributions, usually smaller than the standard distribution, for specific purposes. There's finally an upgraded TLS stack. It's kind of ready for HTTP 2 out of the box, even if there are no APIs for it quite yet. It does allow, in JDK 9, it does allow modern containers like Tomcat 9 or JD 9.4 under Toad 2 to benefit from being set up on JDK 9 by finding the corresponding SSL stack underneath the covers. No modifications of the boot class path or any other special escape hatches needed. And of course, there's Jigsaw. And there's an intention in this order. I actually find the reasons for upgrading to JDK 9 or higher in exactly that order. It's the JVM improvements that I find most attractive. It's the SSL stack that is almost on par. And then there's Jigsaw. Of course, Jigsaw as the module path feature is quite popular in the stories being told, in the conference presentations about it, and there's a lot of design inspiration to be found in it, so it's by all means worth familiarizing yourself with. However, initially, Jigsaw was actually meant for decomposing the JDK itself, and this is where I find the greatest benefits at this point. Creating a custom JVM distribution is a really fine idea. Having the JDK itself decomposed into reasonably sized modules that can be combined into a particular image, but don't have to be, right? And in terms of the default conventions in JDK 9, many of those modules are not active by default, even to the degree of Java util logging not being present by default. JXP, JNDI, some of the additions back in JDK 6 have been kind of moved out to the outskirts of the JDK again, so that you can't rely on their presence anymore. it radically changes, in particular for a framework perspective, it changes the expectations you may have against an underlying Java runtime. What is guaranteed to be there? Well, as of JDK 9, not that much anymore. Java.base is definitely going to be there. Basically, everything else is optional. Which means as a framework or as a library, you should have those optional parts in optional parts of your own code base, right? You can't rely on the presence, even of, say, the JNDI naming exception class or JXB for XML binding. There's a lot of benefit in it, because there was also always a little bit of a weird situation where in the JDK itself, you got an out-of-the-box version of JXB. If you wanted to upgrade it, you kind of had to hack the class path, right, with the book class path and libx and that stuff, right? The idea behind JDK 9 is to have a more streamlined, straightforward arrangement for composing such an infrastructure stack. If you want a JXB version, a newer one from Maven Central, just use it on JDK 9. That, once again, is very natural, the way it used to be before JDK 6, actually. From a framework perspective, there are actually quite a few things that we have to roll back on a little, right? I already mentioned Java util logging, JNDI, and co. There's also common annotations, JavaX annotation, like the resource annotation, post-construct, pre-destroy. Those annotations are not guaranteed to be present in the JDK anymore. And as of JDK 9, it's kind of an optional module. It's actually in JDK 10 towards 11, they are removing those modules. They are not part of the JDK distribution anymore. You have to consume them from an external source, usually from Maven Central. Like if you wanted to use the post-construct annotation, take the JavaX annotation module version 142 from Maven Central, right? And you're done. So from a Spring perspective, we didn't have a particularly hard time here, because Spring actually evolved as a framework before JDK 6 was a norm, so we never really relied on the presence of those things. And because Spring was always designed for compatibility on Google App Engine, and Google App Engine was ahead of its time. For many years already, it provides a customized JVM distribution where certain APIs are not present. So we had to live with this already, and JDK 9 just makes it kind of a part of the standard conventions now for us. So a quick glance at the JDK 9 module graph. Interestingly, quite a few of those modules shown here are disappearing on the way towards JDK 11. There is no java.corba anymore. There is no out-of-the-box JXB anymore. So quite a few things are actually disappearing. There is no web service stack, which actually brought all of those things into the JDK back in JDK 6 anymore in a core JDK 11 distribution, as far as we can tell right now, and as far as has been set up for the early access builds of JDK 11 already. And this decomposition of the JDK was a very, very useful exercise, right? In many ways, this is finally reaching a manageable and maintainable and customizable state of affairs that we can all live with. Now, the same module system can also be used for applications. It is an opt-in choice on your end. You can choose to use Jigsaw for your own application deployment purposes. Basically, to take your jar files, make them proper Jigsaw modules, agree and adhere to those conventions, and deploy your entire layout, deployment layout, using the module path. This is actually a mode of operation, or a mode of bootstrapping. A JVM 9 or higher basically has a class path mode and a module path mode, like literally -cp-mp, right, on the command line. And these are really two modes of bootstrapping with different conventions. If you keep bootstrapping on the class path, there's not too much radical change coming your way. Many things that were possible before are still possible. There's no enforcement of stronger rules. But so, in particular, as an upgrade path, right, for existing applications and existing like Tomcat setups and so forth. If you opt into the module path, you opt into stronger conventions. It's still jar files that you're deploying, but those jar files have to have coherent content, unique packages assigned, no split packages, same package across several jar files anymore, no cyclic dependencies between the jar files, so it really needs to be a clean, straight, modularized arrangement. This can be kind of, well, spiced up with a module descriptor, and this is what you usually do for application purposes. So adhering to the conventions is one thing. Additionally, you may add a module info descriptor to those class files, a little bit like package-info, module-info, compiled. So it's a module info class in the actual jar file. And the module info just says, I require those other modules, and these are the packages that I export. We're going to see this in a moment. You may do this alternatively, and this is particularly useful for libraries and frameworks. It is also sufficient to just declare a module name, a so-called automatic module name, in the manifest of the jar file. No full descriptor, just a well-defined name for the module, a symbolic name for the module, conventions for everything else, runtime resolution of the dependencies, and all the packages exported by default. This is very, very useful. The automatic module feature is used by, well, all the JDK 9 compatible libraries, JDK 9 prepared libraries that I'm aware of at this point. So what does this look like, feel like? Well, it is actually sufficient if the libraries and frameworks that you're consuming have these automatic module name descriptors and if they adhere to the conventions. So if you take, for example, Spring 5 or JUnit 5, you take the standard jar files from Maven Central. They happen to come with these manifest descriptors. If you put them on the class path, those descriptors are irrelevant. The module name is irrelevant. If you put the same artifacts from Maven Central onto the module path in a JVM 9 or higher setup, then, of course, within the module path, the JVM understands, oh, that's actually a unit of deployment for the module path. There's a module name attached. It creates a runtime representation of each jar file. So kind of, you can imagine the JVM retains information about the structure of your deployment. It knows that there was this jar file and that jar file. Each formed a module. There's a module name attached. So there's not only runtime enforcement of certain rules, there's also runtime reflection. You may actually ask a package which module it came from. So there's also new runtime reflection opportunities, which can be quite useful for certain tools, even for certain framework features. And the module info descriptor that you have to ship in each and every module of yours is quite simple. It's literally a new syntax for a module, the well-defined module name of your module, the dependencies that you require. You internally need JDBC, the Spring JDBC module, and the Spring context module in this particular module that is being sketched here. And you export certain packages of yours, because you don't want to export everything. There may be other packages within my appdb that you are not exporting because nobody else needs to see them and use them. This is essentially, in a nutshell, what Jigsaw can do for you at the application level. And this is also, in a nutshell, what we were aiming for the development experience in Spring Framework 5 and also in JUnit 5, which went through the very same exercise. A particular notion here is the module names. So easily misunderstood. The module namespace is totally separate from the package namespace. It may look like a package name, but doesn't have to. The JDK modules themselves don't follow package naming. The Spring, but they rather have java.sql, java.logging. They don't actually follow the implementation namespace. In Spring, we followed our artifact names because we always had a modularized core framework layout, so we followed those. It's spring.jdbc, spring.webmbc, which is clearly identifiable as a module name and not too easily confused with the packages inside, which are org Spring framework JDBC, for example. In your own modules, you may choose to have your own convention for module names, or you may choose to just align with your package naming. And this particular example here says module my.app.db, totally symbolic, but aligned with the package naming inside, which, according to the exports, also follows my.app.db. But it's two different namespaces. You may use a completely different convention if you choose to for the module names. Again, a particular note, because it's oftentimes confused. Modules contain classes, right? And kind of conceal them to some degree. From an external perspective, this includes other modules of yours in your application, but it also includes frameworks and libraries outside. If they kind of look into your module, they only see what's being exported. And exported means public types. We can't see, or we can't access, to be more specific, the internals of those types. So if you want to see, or to read or set private fields or non-public constructors, that sort of stuff, right? Then exports on its own is not good enough for your purposes. You also need to open the entire module or open a particular package within that module towards external consumers. This is no different between your other module trying to access some internals or a framework trying to access them. There's really no difference. So from a Spring perspective, we carefully designed our development experience that you do not need to do this unless you want internals to be accessed. So if you design your Spring managed components as public types with public constructors and public callback methods, there's no need to open your packages in a Jigsaw arrangement. Only if you want to put at auto-wired on like private methods or non-public constructors, then and only then you need to open the packages towards the outside world and towards Spring in particular. This actually works quite fine, and our default recommendations are to use public types, also for testability and for programmatic usage, right? So there's really a fine alignment to be found here. By the way, we can actually see the structure. So if you happen to accidentally put like a Spring annotation on a non-public type, we can see and find it. So we're going to see it and fail at runtime. It's not silently ignored in a usual scenario. We just can't access the field, right? But we can see it. We can find out that you tried to set it up for us, so we can kind of throw an exception with proper context. All right. Last part of the talk and kind of the wrap-up, but a very important wrap-up part I find, is the future beyond JDK 9. This nice little graphic I borrowed from our friends at Azul, because it really nicely illustrates where we're at. There's JDK 7 and 8 at the bottom. The reddish part is kind of the commercial support lines that Oracle declared. JDK 7 is still supported until 2022, JDK 8 until 2025. Then comes 9. Now look how short that line is, right? JDK 9 is only an active release for half a year, active maintenance for half a year. Then comes JDK 10, recently released, just like 2 weeks ago. So we have JDK 10, but it's only an active maintenance release for half a year. As of September 2018, there's JDK 11, the next long-term support branch, which, according to the current understanding, will only have public updates for half a year. Then comes JDK 12, and so it goes into the future. The difference with the long-term support release nature of JDK 11 is that Oracle, and not just Oracle, but also Azul and possibly others, will provide long-term support for it. So you can buy a commercial support contract that extends the support phase until 2026. So the long-term support nature is basically a commercial support statement. No statement about the availability of public updates. Simon Ritter from Azul calls this a support cliff because the public updates don't even overlap. If you want a security fix for JDK 9, but JDK 10 is already GA, you have to upgrade to JDK 10. You're not going to get a public update with that security fix for the 9 line anymore. This is what we are going to see over the next few years here. So JDK 11 is scheduled for general availability in late September this year. Not far off at all. JDK 9 and 10, from Oracle's perspective, are basically just intermediate releases. Technically, they are generations branches at OpenJDK. Somebody else may extend their lifetime. So Azul, for example, considered to extend the lifetime of 9 and 10 for just a little bit longer so that there's an overlap in the maintenance phases. But I guess they would only productize this if there was actually enough demand. The way I'm seeing it right now, this is not really happening quite that way. We will have to adapt to the long-term support branches, and they're only going to come every 3 years. So if you remember the line very up above, the next long-term support release is JDK 17, to be expected for September 2021, in 3 years' time. So we're basically jumping from one long-term support release to the next in terms of production scenarios, which provides really 3 distinct support options towards 2019, towards next year. You may choose to always immediately upgrade to JDK 11, then to 12 in March next year, then to 13 in September next year, and so it goes, right? Be prepared to do this every half year on time, because there may always be a security vulnerability a day after the GA release, right? And the only way to consume a fix for it is to be on this current supported branch. But that is kind of what you can do for development and for purposes where it's totally your own choice of what you're deploying with. In a data center arrangement where somebody else controls or it needs to be negotiated with, right, in terms of the underlying JVM level, you're not really having a valid option here. It's more like you're on JDK 8, hopefully. You may choose to buy long-term support for JDK 8. And Oracle themselves declared that they will provide extended support until 2025, regular support until 2022. So that is an option, right? Basically, you're on JDK 8, buy long-term support for JDK 8. You may also choose to upgrade to JDK 11 as the next agreed-on long-term support release, which is only really a viable long-term strategy if you buy commercial support for it, according to the current understanding how public updates are handled. So basically, your choice is stay on JDK 8 and buy commercial support, or upgrade to JDK 11 and buy commercial support. For the next 3 years, I don't really see another supported option for production environments out there. From a Spring Framework perspective, we're trying to find a balance in between this. We're considering every new release every half year. We're trying to make the framework compatible and adapted to this most recent generation every half year. We put particular focus, at least we expect to put particular focus, specific focus on the long-term support releases, more than on the intermediate ones, just by the nature of the expectations, right? Everything we're doing is just there for you to put an application into production. So if you choose to do this against long-term support releases primarily, we primarily focus on the long-term support releases as well. At this very point of time, the recent Spring Framework 5.05 release is based on JDK 8, so the standard build is JDK 8 based. But if you just switch Java Home to JDK 9 or 10 and rerun the build, it works fine. You may even choose to change our build script and upgrade to JDK 10 language level for the tests, for example, and experiment with some tests and rerun the build. It's still going to work fine. So we have an arrangement that allows you as a contributor, or just as also as somebody running the integration tests, to choose your JDK level to run the current Spring Framework generation on. We expect the same setup with quite a bit of tweaking in certain corners to also work for JDK 11, so that you can choose 8, 9, 10, or 11 as the JDK to run the Spring Framework build and the Spring Framework integration tests on. This is the way we are dealing with it from an open source perspective, right? Best effort support for all the new JDK generations at a reasonable time, and specific focus on the long-term support branches. Personally, this is a quite personal assumption, right? But I expect most people to actually stay on JDK 8 for quite some time. Personally, as much as I despise a future where once again we're stuck on an older JDK generation, it looks like that is going to be very common. It's the easiest way out. If you're on JDK 8, buy commercial support for it, and you're done until 2025, right? Or 2022 at least. And with JDK 8, you can buy commercial support from 4 different vendors. With JDK 11, it looks like it's initially only going to be 2. Right. A couple of upgrade considerations that I have for you. And they kind of follow from what we've been discussing here. For a start, if you want a smooth upgrade experience, stay on the class path. This is a fully supported options on all future JVMs that we are currently expecting. This is not going away. It may not be your choice anyway. If you're deploying to a server container like Tomcat or a full EE server like Wildfly, they run on the class path in any case, right? They provide a higher level deployment mechanism in the form of a WAR file, and underneath it's all class path based. So this is definitely the smoothest path. There's another one that may be a little more unusual to some eyes. I recommend that you consider staying at Java 8 bytecode level. Like, if you currently have a Java 8-based application setup, keep compiling with target 1.8. But try deploying, do a smoke test, on JDK 9, or forget 9 now, right? On 10, in half a year, on 11. Build on 8 with 1.8 target compatibility and run on a newer JDK. This is the best chances you have for surviving the smoke test. Because many of the libraries and frameworks out there do some embedded bytecode processing, and they might not quite be capable of understanding the bytecode level that comes with 9 and 10 and 11. Because every one of those JDK releases formally comes with a new bytecode version. So if you do a standard compilation on, say, 10, it uses a bytecode version 2 generations newer than 8. Like a bytecode library like ASM being used for parsing says, like, I don't know the bytecode version, rejecting it, right? Even if there's no news in the bytecode, because in 10 and 11, we don't actually expect any hard changes in the bytecode. The var feature, the var declarations in JDK 10 are a compiler feature, didn't require any changes in the bytecode. But JDK 10 still comes with a new bytecode level. This is really an almost artificial breakage, right, for many tools. If ASM would try to parse the bytecode, it would understand it, but it thinks it can't because there's a new bytecode version. The way we are handling this in Spring Framework, in the Spring Framework ecosystem, is that we use a ASM fork centrally for all the projects. That ASM fork handles new bytecode versions leniently. We basically remove the assertions for the bytecode version, right? We basically say, like, I don't care what bytecode version it is. We're trying to parse what we need to know, which is the structural information about the class. If we fail, we fail. But it doesn't really matter, right, whether we fail at parsing the bytecode. But there are strong chances that we survive it. And at this point, we do not know about any corner case that is not supported on 9, 10, or 11 early access. So this strategy works very well for us. For tools using standard ASM with the standard assertions in place about the bytecode versions, they may reject the mere nature of a new bytecode level. That's why I recommend, not for Spring purposes, for all the other frameworks out there, I recommend to stay on -target 1.8 and try deploying to 9 or 10 or 11, benefiting from all the infrastructure improvements, having still a JDK 8-based code base, which is a fine language level to work with, and always having the option to roll back. Don't forget about that part. You may choose to deploy on JDK 10 for a certain phase for staging purposes. If you find any issues with some of your tooling, some of your instrumentation setup, whatever it is, right, some of your monitoring setup, if you build your application with target 1.8, you can always roll back to a JDK 8-based deployment, just very easily. Or if 10 works fine for you, if 11 will work fine for you, you can benefit from the infrastructure immediately, your choice. All right, really so much for what I had for you today. Just 2 final notes. Spring Framework 5.0 already came out end of September, late September last year. It comes with the JDK 8 baseline. It came shortly after JDK 9 GA, so JDK 9 is fully supported. It's already prepared for JDK 10 in Spring Framework 5.0.5, basically as of earlier this week. And it comes with all its general stuff, right? The functional API design, story, the reactive web stack. Next up is a Spring Framework 5.1 release for currently somewhere between end of July and early September this year. in particular aligned with JDK 11. And JDK 11 is quite aggressive in a few places. It removes some stuff that was sort of not expected to be removed right away that we have to address. So there's a little bit of work involved in this, but fundamentally we're tracking what we need to do here and intend to provide a full JDK development experience as of end of September when JDK 11 goes GA. In Spring Framework 5.1 and the Spring Boot 2.1 release to be based on it. A little bit of infrastructure upgrades internally to be able to sort this out. Also some new feature stuff in JDK 11 that we consider exploring for our purposes. There's finally a new async HTTP client API that is productized in JDK 11 now. Well, it was just experimental in 9 and 10. And we're trying to see what we can do with it, whether there's any value add that we can provide, any backend implementations using this that we can choose to use by default when we run on JDK 11, that sort of stuff. It's of course not just about the JDK, we also catch up with other infrastructure updates. Most importantly, the Hibernate ORM 5.3 release, which is actually a quite major release. First JPA 2.2 release coming out of the Hibernate ecosystem, and some quite nice SPIs being provided there that are in particular designed for Spring integration purposes. So we're also going to try to do our part, nicely integrating them so that some of Hibernate's backend types can see dependency injection out of the box, and so forth. So there's always more work to do. But from the perspective of this talk, the JDK 11 compatibility story is probably the most important part. All right. Thanks for your attention so far. I'm going to provide yeah, thank you. I appreciate it. I'm going to provide another perspective on it and kind of the complementary parts about the reactive web stack and other hidden gems in Spring Framework 5 that we didn't talk about today in this morning session. I'm going to provide those tomorrow, I think 5 o'clock-ish, in my Spring Framework 5 feature highlights and hidden gems talk. Thanks and enjoy the rest of the show.